Today we are looking at a very practical topic when it comes to the use of measurement technology in electromobility. We are talking about the maintenance of high voltage safe measurement technology, and in particular about calibration and high voltage insulation testing. When we as a consumer purchase a complex device or system such as a passenger car, we realize that it's not just a matter of buying the car, putting fuel or electricity in it, and then driving it around until doomsday. We already know when we buy the car that we will regularly go for maintenance. We will show the vehicle to the TÜV or a similar authority and may have to visit the workshop once in a while if something does not work as it should, or for example, if something has been damaged. So that in addition to fuel or electricity costs, tax and insurance, we should also plan for certain maintenance costs. And it's the same with measurement technology in general. Well, measurement technology has the advantage that it does not consume fuel, but only electricity. And some measuring devices even use very little electricity, and likely you will get to know one or two of them later on. And we usually don't have to pay taxes and insurance for the operation of our measuring equipment, but maintenance costs exist for the measurement technology just like for a car, of course, in a different form. And today we are looking at two important aspects in particular. Firstly, the calibration of the measuring instruments, and secondly, the insulation test, which must be carried out regularly in addition to the recalibration for high voltage safe measuring instruments. So in the roundabout next 30 minutes, we are going to get an overview of what the key points are for calibration and insulation testing, how the whole thing can be implemented in practice, and at the end, you will get a useful checklist from me for calibration and insulation testing. Now, to make things more practical, I'll invite you to join me in a scenario, a realistic situation that could take place at a vehicle manufacturer in exactly this way. And those of you who have already accompanied measurement campaigns and are experienced in this field can of course adapt this in your mind to your own situation. Just imagine you are responsible for the measurement campaign of a new electric vehicle, perhaps a passenger car. And this car is to be on the road for several weeks in a field trial, collecting important measurement data, possibly from the entire drivetrain. You now have the vehicle instrumented, meaning it's equipped with all the necessary sensors, and you also have the required measurement technology put together. Now the date for the departure and the start of the endurance test is getting closer and closer, and when the measurement equipment is to be installed in the vehicle, you suddenly notice the calibration of the measuring modules is now due. It may still be valid at present, but it will expire in the course of the upcoming testing. And your customer explicitly insisted on DAKKS calibrated measuring equipment because these are very important and critical measurements. So good that the measuring equipment has not yet been installed in the vehicle, because it would have been a lot of work now to uninstall the measuring equipment again. And now you notice at the same time that the insulation test for your high voltage safe measurement technology is also due. And this is the final showstopper for you now. So you pick up the phone, you call your measurement technology supplier to arrange an appointment for calibration and insulation testing as quickly as possible. Yeah, and there they tell you that the next possible date is in about 5 business days, which isn't too bad, and that your equipment, if you ship it today, will be out for about 2 weeks. if nothing unforeseen comes up and all the equipment makes it through testing. Now, this is all rather unfortunate for your project planning now, because in 5 working days, you actually wanted to have your test vehicle in the field already. And there is already a huge stress unfolding in front of you at a new problem site. A problem site that has arisen unnecessarily and that could have been prevented. Now, you might say that wouldn't happen with us. We have excellent instrumentation management, reliably planning, and we have this issue well under control. You wouldn't believe me how often we get calls exactly like the one I just described before in summer or winter trails. Each of you, each of us, has so much to do in our day-to-day business that things like that can just happen. True, that's just human nature. So first of all, let's talk in depth about the subject of calibration and what actually lies behind this process. What is calibration in the context of measurement technology? The pure calibration is in fact only a simple evaluation, a comparison of a measured value, a display value, against a normal, meaning a reference value. And for this purpose, you take a very precise signal source, namely a calibrator, which outputs a defined reference signal. And you then look at what reading the device under test gives in the response to the calibrator's signal. Now, reference and actual value are usually not identical, and this difference is the measurement deviation of the calibration object. Of course, this process must be carried out separately for all measuring channels of a device, and also separately with several points per available measuring range. And depending on how many channels and measuring ranges a measuring device offers, this results in a quite considerable number of measuring points that have to be checked. Well, another important information is the measurement uncertainty of the calibration setup, meaning which measurement uncertainty results from the entire setup, namely the generator itself, cables, connectors, adapters, and so on. And for this purpose, a consideration of the measurement uncertainty must always be carried out for the calibration setup and must be documented. And a calibration certificate then contains exactly this information: the reference value, the measured value of the test specimen, the deviation, and the measurement uncertainty of the calibration. And here you can see the measurement results of a calibration that we performed at CSM. Here in front, we have the channel number in yellow, then in blue, the different reference values per measuring channel, and behind that, the measured values of our calibration object. In red, we now here see the measurement uncertainty of the calibration setup, and the green column is the deviation, which is the difference between the reference and the measured value. And at CSM, we offer you another service that many of our customers appreciate very much. And what then goes beyond the pure calibrations is the so-called conformity assessment. This is the comparison of the deviation with defined limit values from the specification of the test specimen, namely what is written in the technical data sheet, and also the error consideration of the complete test setup, our measurement uncertainty. And here in the table, the deviation is divided by the tolerance, and thus we get a percentage statement of how far we are exceeding the limits of our specification. And the result here is simply the statement good or bad. This means, for a quick overview, you can see a summary of the calibration result. In our case, the results are all positive for all measured values. That means that all channels of this device are therefore within the specification. And now there's another advantage to this, because if we look at this percentage value over several calibrations, we can see a trend. So does the value remain constant, or does it become larger and larger? And that can then help you to assess at what intervals the modules should be calibrated. Here you can see the description of the conformity statement, and what is most important for our customers, for most of our customers, is this little table down here. Because actually the user wants to know, can I use my device without hesitation? And with a conformity assessment, this statement is very simple. This conformity statement is not mandatory, but many users like to receive it and they want it. Now let's take a quick look at the difference between a factory calibration and a so-called DAKKS calibration. In a so-called factory calibration, the manufacturer performs a calibration of his own product and generates a certificate, a calibration certificate. And here the customer must then trust that the manufacturer has carried out the calibration properly. Therefore, many users require a so-called DAKKS calibration for quality reasons. For a DAKKS calibration, a calibration laboratory must have a DAKKS accreditation. DAKKS is the abbreviation for German accreditation body. In other countries there are similar authorities, and they are all internationally organized in the ILAC, the International Laboratory Accreditation Corporation. And in Germany, a calibration laboratory can be accredited by the DAKKS according to the DN ISO IEC 17025. This means that the DAKKS certifies to an accredited calibration laboratory that this laboratory works according to the specifications of the DIN ISO 17025 and may accordingly also generate DAKKS calibration certificates. And those are then internationally acknowledged, which is a huge advantage. The DAKKS accreditation is associated with a number of requirements and expenses and a regular audit, and it is also not quite cheap. And above all, this accreditation is also always granted only for a certain measurement. So, for example, only for voltage signals and only for thermocouples, for example. And this is then what it looks like in a DAKKS calibration certificate. You can see here the DAKKS logo with the accreditation number here and the reference to the DIN ISO 17025 standard. And here you can see the calibration object, in this case a thermal measurement module from CSM for temperature measurement, and then of course the ambient conditions such as air humidity and temperature are also recorded, and we also have the reference standards documented, meaning the calibrators are noted. Now let's move on to the question of how often calibration of measurement equipment is actually required. And to do so, we first need to know when the last calibration actually took place, or even better, when the next calibration is due again. And in the configuration software of the CSM modules, for example, you can read out this information from a measuring module. So here you can see now the date of the last calibration and at which calibration laboratory it was performed. And you can also set a calibration interval in the software, here now 365 days, and then set a warning at an advance warning time, here in example now 30 days, which informs the user that the calibration is due again. And then when the configuring the modules, maybe when you check your configuration before you write the configuration into the devices, a message comes up that the calibration is now due again. It's very useful. The other possibility is, of course, that you simply look at the label of on the device housing if you have the device at hand and it is not, for example, installed in such a way that you no longer can read the label. So, but what is the correct calibration interval? How often do I have to have my modules calibrated? And the answer to that question is, it depends. So what does it depend on? It essentially depends on what requirements you have for the measuring accuracy of your device. And it follows that you as the user also determine your own calibration interval. Because depending on the application and the goal of the measurement, these limits can be more or less stringent. For a rough functional test, you may not need the same measurement accuracy as for the release measurement for the next development milestones. And your manufacturer does usually not know all the applications in which you use his devices. And so you, as the user, are responsible for evaluating whether the measuring device still meets your requirements. So ultimately, it depends on your quality requirements of how often you calibrate or on the quality requirements of your customers. As a manufacturer, we only recommend a calibration interval, and this standard interval is 12 months at CSM. There are also customers who decide to set the interval to 24 months, for example, on the basis of a detailed analysis of their application profile. However, in recent years, we have made the experience that more and more customers demand a 12-month calibration and oftentimes also demand a DAKKS calibration. And if your measurement technology is then only factory calibrated, then of course you will have to bear additional costs for a DAKKS calibration. Therefore, it's also financially advantageous if the manufacturer of the measurement technology offers a DAKKS calibration for its devices itself. By the way, you should also make sure that with high voltage safe measurement technology, the large measuring ranges for voltage and especially also for current measurement can also be calibrated exactly. For this, the calibration laboratory needs suitable calibrators and test methods, and in CSM calibration laboratory, this is of course possible for all our measurement modules, also including the DAX calibration certificate. So now we have talked about calibration so far, but not yet about the question, what actually happens if my device is not in the specification anymore? Because then further measures would be necessary to restore the functionality of the device. However, these are not part of a pure calibration. And it is therefore important that you take a close look at what is part, for example, in an offer for recalibration of your measuring instruments, namely what is actually included there. With a pure calibration, only the status quo is recorded. Well, we have made the experience that in the end, it is simply important for our customers to have a fully functional and precisely measuring device. And that's why we offer the calibration as part of a maintenance package. And this maintenance package includes a visual inspection, it includes a functional test, and of course, a calibration. A first calibration, because only if required we have an additional adjustment of the device. This means if the device or a channel of it is out of the specification, then we as a manufacturer can generally rectify this shift by a so-called adjustment, an electrical readjustment of the device. And after the readjustment, of course, a second calibration is then performed. It is important to know that if a device has to be adjusted, this can usually only be done by the manufacturer himself. This means that calibration service providers are at a disadvantage here because they also have to send the devices to the manufacturers for adjustment, which costs, of course, additional time and money. So with this, we close the chapter calibration at this point and come now to the high voltage insulation test. So why do we have to carry out a high voltage insulation test at all? And the most important, the central reason is this. High voltage measurement technology is used to collect measurement data in high voltage systems. We work there with system voltages that are far beyond the safety extra low voltage of 60 volts. We are dealing with voltages from 400, 600, 800, over the 1000 volts sometimes. And now, to make matters worse, we are not just dealing with high voltages. If we look at a power fence for cattle, for example, we also have high voltage, but we have very low current. If we touch it, the flashover is just a little bit unpleasant. But in an electric vehicle, we have a high voltage battery, and this has an extremely low internal resistance. This means beside the high voltages, we also have to deal with very high currents, sometimes already over 800 amps in passenger cars. And this combination is highly dangerous. Dangerous for our electronics, and it may also be deadly for people. And for this reason, we at CSM have developed a comprehensive safety concept for a high voltage safe measurement technology, which in addition to high voltage safe cables and high voltage safe connectors, we see them here, also includes a high voltage insulation barrier, and this per measuring channel in the measuring device, namely for each individual measuring channel individually, because the different channels must also be electrically insulated from each other. And this high voltage barriers undergo aging due to a wide variety of influences. For example, by over temperature, over voltage, strong vibration, and also simply by aging over time. And that is the reason why the safety of a high voltage measurement devices must be checked regularly. Of course, this also has legal backgrounds, and that's exactly what we do with the high voltage insulation test. So what exactly does the high voltage insulation test include? At CSM, the insulation test is carried out exactly according to DIN EN 61010, and you can mark the standard when it comes to high voltage safe measurement in general. And as part of the test, a flashover resistance between different potentials on the high voltage measurement device is tested, namely all measuring channels against each other and all measuring channels against housing and sockets for bus connection, for example, the so-called self. For this purpose, we connect a high voltage generator to our measuring device using suitable measuring adapters. And then a test voltage of 3100 volt DC is established by means of a ramp for 5 seconds and then held for another 5 seconds. And if the test was successful, then a high voltage test certificate is generated for the device. So in this certificate, the complete test is documented. Incidentally, you will receive this certificate with every CSM high voltage measuring module as part of the so-called piece test or routine test upon delivery together with the device. This is an integral part of our production process. Type testing of a high voltage measuring device is performed at even higher voltages and is much more extensive and expensive than routine testing. And now you're probably wondering how often you have to perform this high voltage insulation test. And here too, we can only say it depends. Well, we specify a standard interval of 12 months, for example. And this then fits very well with the calibration cycle of the module, for example, and you can have both tests carried out in one order, which of course also saves logistic costs and time. So with this, we have also checked off the standard procedure for high voltage insulation testing. However, there are also certain cases in which it is advisable to check your high voltage measurement technology much more frequently. And this again depends on your application spectrum. If you often operate the device in the limit range, then you should, for example, think about a high voltage insulation test before each new use of the device, because you may not know what has happened to the device before. In the end, it's like with your car and the TÜV. If you bring your car to the TÜV, then it also only means that exactly on this day the inspector has checked your car and certifies that everything was okay on this day. What is then in 3 months? Who knows? Therefore, once again, it may be well advisable to check the high voltage measurement technology much more frequently than every 12 months. And that is, of course, a more time-consuming matter if you always have to send the devices in for high voltage insulation testing, because this also increases the logistical effort immensely, and that costs time again. And this raises the question, who can actually perform this test? And there are basically two possibilities. One is the manufacturer of the equipment. And the other option is you do it yourself. You can also do this test yourself. And what you need is a copy of the high voltage insulation test stand that we at CSM run here. So you can purchase a complete high voltage insulation test stand from us and use it to test all your high voltage measuring instruments yourself with as many times as you specify. Of course, we are also available to you to advise you with our experts. So what does a high voltage insulation test stand look like? It basically consists of a PC with a special testing and control software developed by CSM and a high voltage generator, then the appropriate cables and adapters for wiring all together, and very important, special test boxes for self-testing of the entire test setup. These test boxes are module specific, meaning they are corresponding test boxes for different module types. And then you simply get the test boxes from us for the device types that you want to test. And the whole thing then goes like this. First, the setup checks itself completely with this test box to make sure that all the cables and connectors are okay. And then you connect your modules, the modules to be tested one by one, and the software does the rest completely by itself. And at the end, you get the certificate for each test item as a PDF file. Very simple. Now let's take a look at the advantages of the high voltage insulation test station. The logistics are completely eliminated. The measuring modules are only gone for a few minutes and then immediately ready for use again. You are free to choose your own inspection intervals. Especially for demanding operations, it is worth its weight in gold to be able to inspect before each use. You can also use the high voltage generator for other tests, for example, to test your high voltage cables. Well, this is not part of the CSM test software now, but it works in principle. You have a one-time investment for the software license and the hardware, and then only regular maintenance contract costs. And if you introduce a new type of module, for example, you simply buy the corresponding test box and you can test these modules as well. And the software is kept very simple, easy to use, and self-explanatory. And of course, you also get a full documentation. And by the way, it's the same for calibration. You can also purchase a complete calibration station from us and then calibrate your modules on site, on your site. Of course, you don't have the DEX accreditation as a result, but if you have a lot of modules, you can also make your life much easier here. And with that, we also looked at how we can avoid time pressure and ensure faster inspection intervals and thus higher operational safety. And here comes the checklist I promised you at the beginning. We have put together a short and concise list of what you should pay attention to when maintaining your measuring devices. Check regularly when the calibrations and the high voltage insulation tests of your devices expire. Either look on the device, where it's usually a sticker, or use the readout function in the CSM configuration software. It will also show you the expiration date. Then give us or your calibration service provider plenty of notice of your upcoming calibrations and high voltage insulation tests, especially before the major measurement campaigns in early summer and late fall. Always plan for shipping time as well, both outbound and return shipping. Think of stocking spare modules to be able to compensate for failures. Then save the measurement configurations of the measurement modules before you send them in. They are normally not deleted, but better safe than sorry. Another insider tip: take advantage of the price for the combined calibration and insulation test package for high voltage measuring modules. You can save another 20% on cost here. And if you simply have a certain number of measurement modules, or you have heavy traffic on your modules, then really put your hand on your heart. Seriously consider the purchase of a high voltage insulation test stand and possibly also a calibration test stand. You are welcome to contact us about this later. Well, here is the complete checklist if you want to take a quick screenshot. I hope that I could give you a comprehensive overview over the maintenance of high voltage safe measurement technology and possibly one or two decision-making aids along the way. Because measurement technology is like a good knife. You should always keep it sharp. And your whetstones are calibration and the high voltage insulation test.